Okay, so what we'll do in this session is just some basic maths that you need for the economics course of the CFA. Okay, the first thing that I'm going to explain is this concept of y is equal to mx plus c. Since we have so many graphs involved, this concept is something that you need to know. I'm sure you studied this at some point, but I'm just going to give you a refresher. The core point is that if you have your y-axis and your x-axis, any line can be represented by the equation y is equal to, so like this line, any line can be represented by this equation. What this equation is saying, that for any point, let's say point A, the y value is equal to m, some number m, times the x value. So this is some x value and some y value. So effectively what we are saying is the y value is equal to some constant m multiplied by the x value, which is, let's say, this is your x value, this is your y. So the y value is equal to some constant m multiplied by x plus c. Now let's say for this particular line, this point over here, this is called the intercept on the y-axis or the y-intercept. That would be c. How do we know that? On the y-axis, what's the value of x?
0.
Yeah, the value of x on the y-axis is 0. So if you make this 0, so if instead of x you put in 0, then you simply have y is equal to 0 plus c. So essentially then y is equal to c.
At that point?
Yeah, so at this point, what's the value of x at this point?
0.
0. So when the value of x is 0, if you plug in 0 over here, what must the value of y be?
C.
Yeah, so if you have 0 on the, so the y-axis is the same as saying x is equal to 0, right? So on the y-axis, you have x is equal to 0. When x is 0, the value of y must be c. And we then often say the y-axis intercept is given by c. Okay, so that's one point. Now, so that's the interpretation of c. What's the interpretation of m? The interpretation of m is that it is the slope of this line. So sometimes we'll say m is the slope. Sometimes you will hear the term gradient. And sometimes you might also see the change in y over change in x. And sometimes you might see this written as dy dx, which is the calculus way of writing this. All these four things, at least in the context of a straight line, are equivalent. Now what do I mean by this? Let's again just draw the same graph. So say you have a line like this where the y-axis intercept is 2. So effectively, how would we write this point in coordinate geometry? You would just say x is 0, y is 2. Okay, so now in my y is equal to mx plus c, I know that any straight line can be written like this. So without doing any work, what do I know about c?
2.
C must be 2. Okay, next we are going to learn how to come up with m. M, remember I told you, is the slope of a line. So what do we mean by slope? By slope of a line, what we mean is that if x changes by 1 unit, so if we go from, so this point is 0, 0. So if x value over here is 1, so if we go on the x-axis by 1 unit, so let's say this is the point 1, and let's say the y value over here, just as an example, let's say that the y value here is 4 at this point. So let's say that that point is written by 1, 4. I hope you all remember from your coordinate geometry that a given point can be represented by something like 1, 4, where 1 is the x value and 4 is the y value. So what is the slope of this line? The slope is the change in y divided by change in x. What is the change in x in my simple example? The change in x is simply 1. What's the change in y?
2.
Yeah, change in y is 2 because it's 4, this is 4 and this point is 2, so the change in y is 2. So the gradient of this is equal to 2. M, we can say,
2 upon 1.
is 2 upon 1, which is 2.
2.
Okay, so another way of looking at the gradient is it's the change in y for a 1 unit change in x. Do you get it?
Yeah.
So very simple, change in y. The other way of doing it is whatever the change in y is. So if I just give you another line like this, just as an example, so I just give you something like that, and I give you 2 points. I again say this is 0, 2, and I say that this point is, let's say, 4, 12. What's the gradient of this line? The way you can find the gradient is, what's the change in y? 10. What's the change in x?
4.
The change in x is 4. So what's the gradient of this line?
10 upon 4.
10 upon 4. The change in y over change in x, yeah.
So one question, in the previous graph,
Yeah.
we had a certain point 1, 4. Now if we move up higher on the line and take another point,
This is a different line
no,
now.
I'm talking about the first graph.
Yeah.
This one. Let's say instead of 1, 4, we did, for example, 2, 7.
Okay.
So then, what you had explained in the earlier class about as you move up.
Yeah, actually, on that same line, if you go to a point where x is 2,
Yeah.
what will y be?
Y could be 7.
It not could be, it can only be one thing. As in, if you have a straight line, and x is 2, there is only one possible number that y could be. Double of what?
Double of the x value.
No, because we also have this intercept. Remember, so I'll explain 2 ways. This is a good question. So on this particular case, so what was the equation we came up with? What did we calculate m to be?
2.
We calculated, so the equation of the line is 2x. What did we say c was?
2.
Also 2. So now if you plug in x is equal to 2, so if x is equal to 2, what must y be equal to?
6.
Y must be equal to 6. It can't be anything else.
Okay.
So y has to be 6. And it makes sense, right? Because if you go from this point to this point, what's the change in x? From 1 to 2, the change in x is 1. And the change in y again has to be 2. Right? Otherwise you would not have a straight line. Otherwise you would have a kink. Right? For this to continue to be straight, then another change of 1 in x must mean that there is a change of 2 in y. Okay, that's what the slope means. Now, if this was the first line, now I'm talking about a different line. So on this different line, we've already said that the intercept is 2, so the c must be 2, and m must be change in y over change in x. What's the change in y? 10. What's the change in x? 4. So m must be 10 over 4, which is 2.5. So you must have y is equal to 2.5x plus c. Oh, I'm sorry, plus 2. Okay, now any x value you plug in, you can find the y value. And also note that 2.5 is simply saying that for a 1 unit change in x, so if we are at this point here where let's say x is 1, if x is changing by 1 unit, by how much is y changing?
2.5.
Yeah, y is changing by 2.5, so you can, without doing any further work, you can say that y must be what?
4.5.
Y must be 4.5, it must be 2 plus 4.5, and you can see that over here also. So if y is equal to 2, if x is 1, 2.5 into 1 plus 2, which is 4.5. So once you have this equation, you can basically, given an x value, you can find a y value, given a y value, you can find a x value. Okay, now the next point, okay, so now the next point is, very often you might have something like this, 2y plus 3x is equal to 9, just making something up. Now, can you just look at this expression and say that we have a straight line? Yeah. If you just have a y and an x, no squares, no under roots, no exponentials, then you know you have a straight line. But can you just look at this and say what the straight line looks like? Most people can't. But what you can do is convert this into y is equal to mx plus c format. So how can you do that? You can simply say 2y is equal to minus 3x plus 9. What we've done is subtracted 3x from both sides of the equation. Then you divide both sides of the equation by 2. So then you have y is equal to minus 3 over 2x plus 9 over 2. Okay. So what is your c? 9 over 2, which is 4.5. What's your gradient? Minus 3 upon 2. So the 9 upon, so now we can draw this without doing much other work. So when we draw this, if this is your x, that's your y. What's the intercept? 9 over 2. So you know your intercept on the y-axis is 4.5. Okay, what does a negative 3.2 mean?
This way.
Yeah, means that for a 1 unit change in x, there is a negative change. And the reason I'm doing a negative here is because all demand curves, practically unless you have a Veplen good or something, it's a negative. So I'm going to tie this to our demand curve later. First you just need to understand the basics. So what we are saying here is for a 1 unit change in x, so if x, what's x value over here? 0. So that point is really 0, comma, always we write x first. Then if x comes to 1, so that's 1, what's y going to be? Actually,
x is 1.
Yeah, if x is 1, then we need to come down by how much?
3.5.
Yeah, exactly. We need to come down by 1.5. So this really needs to be 3. So if x is 1, y must be 3.
So one second. If x is 1, minus 1.5, right?
Yeah.
So
the slope is equal to minus 1.5.
Right.
So that means if x changes by 1 unit, the y must change down by 1.5 units.
So 4.5 में से 1.5 कम करेंगे.
Yeah, if you reduce 1.5 from 4.5, you come to 3. So if this y value is 4.5,
we get moved in the opposite direction because of the negative.
Yeah. Right. So opposite means, negative means that a 1 unit increase in x means a 1.5 unit decrease in y. And what would a 1.5 unit decrease if we were decreasing x? That means y would be increasing. So a negative sign means that x and y are moving in opposite directions. And that is why the slope of this curve is going to be negative, because a top left to bottom right line means that an increase in x results in a decrease in y. Yeah, so this looks like a demand curve. Now, the way so hopefully this basic concept is clear now. Whenever I say y is equal to mx plus c, the reason the world loves to write things this way, you can just look at that expression and say, okay, what's the intercept, what's the slope, and you can just quickly draw it out. Okay, so this is your basic y is equal to mx plus c. Now if you sometimes, if you are given okay, now let's tie this to the demand curve.
The questions are good in that curriculum.
Yeah, the curriculum questions are great. So that's why I keep saying if you do the curriculum
questions.
questions.
Do one or two of them. So I think the concept.
Okay. So actually, I'll do that in the next segment. Right now you've understood the core maths.
Yeah.
Now the next core maths is the basic calculus. Okay. So let's talk about some basic calculus. What happens here? I'll just first tell you what you probably learnt in class, I think 10 or 11. If you have an expression like this, again y is equal to 2x plus 1. What calculus is telling you, basically, you will see something like change in y, d means a small change, delta actually is written as d. You will see something like dy over dx. This really means for what is the change in y for a small change in x. You can read this as change in y over change in x. And the way you do a change in y over change in x is, I'll just give you the answer and then tell you how it is done. So if you have an expression where y is expressed in terms of x and everything else is constant, one simple point for the level of calculus we are doing over here is we just look at the relationship between two variables. Any other variable, if you have things like z or income or price of another good or whatever, just we keep those constant when we are doing change in y over change in x. Remember, often you might have heard of elasticity, let's say price elasticity. It is the change in quantity when the price changes of that good, keeping all else constant.
But that will be change in x over change in y, right?
Yeah, actually, yeah, but right now just understand this core point. If you have y is equal to 2x plus c, change in y over change in x means any other variable is kept constant. So that 1 simply means all other variables are equal to 1 and they are kept constant. So change in y over change in x is 2. How does this happen? The way you do calculus is you simply take the exponent. What's the exponent of x? It's x to the power of 1. So when there is a long derivation to this which you don't really need to know. All you need to do is when you do differentiation, the exponent comes over here. So you do 1 multiplied by 2, and from here we do x, the exponent minus 1. Okay. So when you do, what's x to the power of 1 minus 1? 1 minus 1 is 0. X to the power of 0 is 1. Anything to the power of 0 is 1. So x to the power of 0 is 1, so the x disappears. Okay. And when you multiply 1 by 2, what do you get?
2.
You get 2. So dy by dx is 2. I'm going to do another example, but before I do that example, I want to show you, isn't this 2 also the slope of the curve?
Yeah.
Okay, so all we are saying is that if you have an expression like, can you just plot this easily? So this is y is equal to 2x plus 1. What's this? The change in y over change in x is also the slope of this curve, right? And we just saw that the slope of that curve is 2, because a 1 unit change in x will create a 2 units change in y, so the slope is 2, and the calculus way of coming up with that is doing the dy dx, which gives you the same answer.
Yeah.
Fine? No? Okay. Now let's make this slightly more complicated. What if we have y is equal to x squared? Okay, for now let's say that there is no constant. Now if we plot this out, this is a simple parabola. So this is your y, this is your x. Y is equal to x squared looks something like this. Okay, so this is your y is equal to x squared. It's always positive because if let's say x is minus 1, what's y going to be?
1.
1. If y is minus 10, x is minus 10, y is?
Minus 100.
100 plus.
Yeah, so, yeah, if,
100 plus. 100 plus.
yeah, exactly. So if x is minus 10, y is 100. If x is 10, y is 100. So that's why you have, y can never be negative in this case. Okay, now unlike our straight line where the slope was always 2, so in our straight line like this, the slope is the same no matter where you are. Can we say the same about this parabola? No, the slope is different depending on where you are. The slope at any given point in time, let's say where x is equal to 1, the slope of a curve is given by what's called the tangent at that point. So this is supposed to be a straight line which is tangent at point A. Let's say that the x value of A is 1. What's the y value going to be?
1.
Also 1. Okay. So that you can just get from this expression. Now, how do you figure out the slope over here? Unlike a straight line where you could just go along the line and do the change in y over change in x, with a curve it's slightly more complicated. Here you have to use calculus. Remember, calculus was telling you that change in y over change in x. What did I say about the method for doing this? You take the exponent and bring it here, and you subtract 1 from the exponent. So if you subtract 1 from the exponent, you have 2 minus 1, which is 1. And what do we have here as the 2? So the change in y over change in x is equal to 2x. So notice that what this is telling us is that the slope depends on the x value, which makes sense. So if the x value, so at x is equal to 1, what is dy dx? So at x is equal to dy dx, we've already said is 2x. If x is, you plug in 1 over here, you have 2. So dy dx is 2. So what we are saying is that at this point A, when x is 1, the slope of that curve must be 2. Right? So this is when you have a curve, the slope is derived by first coming up with the change in y over change in x. And then you can just do the calculus and come up. So at this point, let's say this point B, what's the xy? 0, 0, right? So what's the slope? Slope is change in y over change in x, which is 2x. When you plug in 0, what do you get for the slope? 0. So at point B, the slope, so the tangent is a straight line. What's the slope of a straight line?
0.
The slope of a straight line is 0. Why? Because what draws the definition of the slope? It's the change in y over change in x. No matter how much you change x, what's the change in y on a straight line? 0. 0 over anything is 0. What is something over 0? Yeah, this is undefined. Okay. Now, what about if you take a point D where x is minus 2? So if x is minus 2, what is y? If x is minus 2, y is
Minus
Positive
x square 4.
exactly. Okay. So take some time to wake up on a Sunday morning. So if x is minus 2, then y is 4. Now what's the slope at this point? At this point. Can you see that the slope is going to be negative? The tangent there is clearly,
Yes, negative.
is it negative or positive?
If it's positive, it's like
Actually, this is a positive line. This is a negative slope. Anything that goes from top left to bottom right.
It's like a demand, except the demand is on this side, but with demand curve we see the
Exactly. Demand curve is also downward sloping. What's the slope of this curve?
minus 2 into 2.
So the slope of this is, remember we already derived this. So the slope is minus 4, which makes sense, right? Because it is going top left to bottom right. So notice that 1 unit, when you decrease x by 1, y is positive. Or another way of looking at it is, if you increase x, y goes down. So x and y are moving in opposite direction over here. So clearly the slope needs to be negative. Okay. So this is your basic calculus. Now what we'll do in the next, actually what I want you to do now is, the way this, when you do the problems in the book, you will notice relationships in terms of price is equal to 3q plus whatever 5. Price of a given good is expressed as 3q. This might be a supply curve because there is a positive relationship between P and Q. If you have if you have a demand curve, you might have P is equal to minus 3q plus 2 or whatever. So you will notice, based on what you've just learned, now when you go and look at the mathematics that they do, it should be relatively straightforward. Another thing that you will notice is, if you look at total revenue, will usually be a function of, will depend on, let's say, something times the quantity sold squared. Okay, and then there might be some other constant B. Now, what's marginal revenue? So it's the change in total revenue divided by change in quantity. The curriculum writes it this way, but those who know calculus can then also write it change in total revenue divided by change in quantity. So how would you come up with the marginal revenue in this case? So given that marginal revenue is equal to the change in total revenue over change in quantity, now that your basic calculus has been refreshed, given this, what would you write? You would bring the exponent over here, so you would have 2a multiplied by q to the power of 1. So that's what the curriculum often does in terms of deriving marginal revenue from the total revenue expression. Okay, so that's it for this quick maths tutorial.